Hello everyone, it's been a while. For this tutorial, I'm going to be going over triggers, Boolean expressions, and force group enumerations to do evaluations. Now with this map, I've actually set it up beforehand because the first time I attempted this, I ran into problems with World Editor. I didn't want to recode everything I did. So first, let's go ahead and look at the map to see what I set up here. On this map, I have placed two footmen here, and what we're going to do is make it so when this footman kills the other, or when either one dies actually, it's going to respawn. So while learning triggers, we're going to be learning about how to respawn things, like creep camps in ORPGs and whatnot. This does use a very simple respawn algorithm, so I wouldn't use this direct code in ORPG, but it can be modified a bit and work brilliantly. So to begin with, we're going to look here to see something I set up, the pan camera thing. And all I'm doing here is a group enumeration for player 0. So end up selecting this unit right here. And then I'm just panning the camera to that unit. And this will work for all players because this is a local code native. So let's go ahead and try that out to see what happens. And there it goes, it panned directly to that unit. Now if you notice right now, this footman is not respawning. That's because right now I have the code disabled for that. But let's go ahead and start working on that. So to begin with, we'll have our on init here. And as you see, I have, we probably want a struct. Struct tester extends array. There we go. And struct. And then we have two methods here. This is sort of set up like a main method for C++. It just delegates commands. So here we have the enter init and respawn init. So let's go ahead and make those two. Stack method enter init takes nothing, returns nothing, and private static method respawn init. And alternatively, I could put these into two different modules and implement them into tester, but I'm not going to do that. So to begin with, a trigger is a group of code. It has conditions and it has actions. To start with, I'm actually going to create a trigger in here. Local trigger T, create trigger. Then we're going to have an action and condition. Action takes nothing, returns nothing. And private static method condition takes nothing, returns Boolean. And to add conditions and actions to a trigger, use the trigger add action native. Notice here it returns a trigger action. And the trigger add condition native. And here it adds a trigger condition. Oh, and we should probably convert that to a Boolean expression, because notice here, it takes a Boolean expression, so we use the condition native to convert it. And then we can go ahead and run that, and that is done with the trigger execute and trigger evaluate natives. Now notice here that the trigger evaluate returns a Boolean. So what's normally done is now right here I'm returning false in this condition, and this is because when trigger events run, if this condition doesn't return false, then the actions will be arrayed over even if there are no actions there. So it's just a little bit of a performance tip. And here we can go call display. Actually, condition and print action. And we'll make this return true, that way the action runs as well. Oh, looks looks like I got a typo there. Yep. And there it goes, condition and action. You can add multiple actions to triggers, multiple conditions to triggers. You can even add the same action multiple times. Here we go. Add it twice. You can add the same condition multiple times, and as you see, it ran twice. And if this returns false, if any of the conditions return false, the actions won't run. So right there. Only the condition ran. And if we try making another condition that returns true, condition 2, true, and add that, should run both conditions, but the actions still won't run because one of them returns false. And as you see. So the conditions in a trigger evaluation are linked together by ands. So if condition 1 and condition 2 and condition 3, etc., do actions. So just a little handy tidbit of information. However, once again, you don't want to use actions at all unless you really need that trigger sleep action in there, or you're doing some sort of syncing. So we're not even going to be worrying about actions here. And the reason is actions are much slower than conditions because of that setup to be able to do syncing and trigger sleep actions. Also, if you remember here, they return trigger conditions and the other one returned a trigger action. So you can actually remove triggers and actions from a trigger. If we go here and do a local trigger condition tc equal trigger add condition, then we can go call trigger remove condition tc. And if we do a trigger evaluate, it should not run now. And as you see, nothing ran. Now, conditions are a little bit unsafe to remove. If you remove an action while that action is running, you're not going to have any problems. The other actions will run just fine. But a condition, if you remove it, all the conditions after it will not run. If you remember in a linked list, the prev, next, etc. So pointer 1 points to pointer 2 and pointer 3. Now let's say pointer 2 is currently evaluating, and we're going to remove it. So now pointer 1 points directly to pointer 3, and pointer 2 points to nothing. And so this is why, I think trigger conditions will not run if you remove them while they're evaluating. Trigger actions, on the other hand, will, as I said before, and they work the same way, pointer 2, point 3, etc., except while they're looping, they have look ahead equal point 2, evaluate point 1, and then set, let's try this instead. So set look ahead equal next, evaluate current, and then set current equal look ahead. So this means that even if this is removed while it's evaluating, it's still going to be able to get it because it stored the look ahead beforehand. It stored the next pointer. So that's why trigger actions should run, because they'll never be able to break since it's stored locally. Anyways, off of that useless information for now. Well, sort of useful, I guess. Let's go ahead and try making this trigger run. And we do this with trigger events. And when an event occurs, it loops through all the triggers registered to it and it runs them. It first does if evaluate, then call trigger execute, or whatever. It does that in C++ though. And so that's why, again, you always want to return false. That way you can get a little bit of a performance boost to avoid that action loop. So let's go ahead and register an event. I must note that events cannot be unregistered from a trigger. If you want to clear events out of a trigger, you have to actually destroy and recreate the trigger. And this can be an issue with things like damage detection systems, because event unit damaged, this event right here, there's no player unit event for this. So you can only register it to specific units, and then if that unit goes out of scope, if it's like killed and decays or it's removed, that event stays in memory. It stays registered. And it will stay there and stay a leak forever and ever until the trigger is destroyed and recreated. And so that becomes a tricky issue when dealing with damage detection systems. And other such systems, there's the event unit or in range event. So if you wanted to have a trigger that ran whenever a unit came in range of another unit, you'd have to end up recreating this all the time. So let's go ahead and try registering an event called trigger register player event. How about that? Or rather player chat event. And then it'll be 4t. We don't need this local here anymore. And now it takes a player, so how about player 0, and then hello, true. So now when I exactly type hello, because of this flag right here, it's going to run the conditions. And we are going to go ahead and get rid of this stuff, and now it should run when I type hello. Hello. Notice it didn't run this third time because I had a 1 at the end of it. It has to be an exact match. Hello. It didn't run that time because it still was not an exact match. So let's go ahead and do something that's actually useful with these triggers. Now that we know how to create them from scratch, add actions and conditions to them, run them from scratch, and remove actions and conditions from them, as well as register events to them. And to do this, we are going to go ahead and have a look at the code I disabled over here. Let's first take a look at enter init. Now over here I'm creating trigger enter. So that should happen when a unit enters something. I'm now retrieving the world region, or rather I'm creating a region that's going to be the world region. I'm now getting the world bounds, and the world bounds is this entire square here. So it's this rect. And is newly created whenever this native is called. So be careful of that. Now I'm creating a new group. Then I have a couple of locals here. Now I'm adding the rect, the world bounds rect, to the world region. So that's probably why I named it world. And then here I'm registering the trigger enter to run whenever a unit enters this world region here. So whenever a unit enters this space, this trigger is going to run. Then I'm adding this condition function, this type on enter, to the trigger. So now this condition will run whenever a unit enters that space. Then over here, I am grouping all the units in the area, and I'm doing this so that I can flag the trigger to run. Because what happens right now, the trigger is all set up, but these units are already placed. So they're there, and if you register a trigger to a region, the units within that region aren't going to flag that trigger. They have to actually leave the region and re-enter it in order to set the trigger up. And this becomes a tricky thing in things like unit indexers because they depend on this event right here. So they actually have to do a group enumeration in order to get all the units down. So here we go. I'm enumerate over every single unit in the rect. So here's the rect right here. I'm using the world bounds rect. So it should catch these two units here. Then I'm doing a first of group loop. so the standard start of it. And all I'm doing is setting the X to way out here, so the max X for the world bounds. So call set unit X get rect max X R. That moves it to the edge of the map, and then I move it back to where it was. Do you notice here I use this local that I declared up here in order to save the X so that I can move it back and forth. And this will just move the unit out of the region and then back into the region. That way it will flag this trigger. And this trigger on enter registers the unit for respawning. So without this trigger, the units will not respawn at all, even with this respawn in it. Now I could modify it a bit so that they would respawn without the world region trigger. But I am not going to, because the world region trigger makes it so that whatever units are currently placed, their positions are saved. That way they continue to respawn at that location that was initially saved for them, even if they move to a whole other place. With a more naive system, they will actually respawn at the place they died at, because they don't have this on enter thing that initializes them to a specific position. Also, if you notice, I am doing it somewhat sloppily. I am actually saving this position to the specific unit here, not to the unit type ID. And actually, I guess that's okay, because we don't want all units of type footmen to respawn at this specific location here or this specific location here. So this is actually a pretty good approach, but could be done better with something like a unit indexer. And regardless, with this approach, it's going to have to continue to be refreshed. And what happens when it refreshes is it will die, then later it will be respawned. Then when it's respawned, it will enter this region here and be re-registered with the respawning trigger. Now let's take a look at the on enter here to see how it actually respawns. So if the unit is a hero or if it's a structure, then it's returning false. So heroes and structures should not respawn, only regular units should respawn. That's going to allocate. Notice here I have alloc implemented, so it's going to allocate a new instance, and it'll save that instance to the unit. Get handle ID is just converting the unit handle into an integer, so it's completely unique to that unit. And then the respawn loc, so this is the location to respawn at, will be where the unit was placed. Respawn facing will be the facing that the unit currently has. And then there's a respawn timer, which is later used to actually respawn. If we look on death, call timer start respawn timer for 5 seconds. So that's a delay of 5 seconds there. Let's go down a little bit. Here we're saving the instance we allocate to the timer as well. So there's the get handle ID respawn timer. Then after this, we're setting the unit type ID. Notice up here it's a field, so it's like set this dot unit type ID, set this dot respawn timer. So we're setting the unit type ID to the current unit's type ID. That way it respawns the correct unit type ID. And then the owner is the current owning player. That way it's respawned for the correct player. And then it returns false here to save on efficiency so that it doesn't run the actions afterwards. On death, let's first look at respawn init now. Respawn init creates a respawn trigger. It's local here. It registers an event player unit death event for every player, so that whenever a unit dies, it runs this trigger. And then it adds the condition on death, which is right up here to that trigger. And it sets respawn to null just to clean up that pointer. So if we look at what happens when a unit dies, if that unit is a hero or a structure, immediately exit. So that's not really a necessary check because of this condition right here. We could actually just check if this is equal to 0, then exit. But the check is in there for some reason. Let's just get rid of it. Yeah, this check is all we really need for this. So let's get rid of this stuff here. Because this is going to be... No, actually we do need that check. Well, no, we don't. Now, the reason I initially had that check in there was because if I didn't have this remove save integer call right here, that instance would still be saved to the unit. So later on, this value would be loaded up. It would load up a correct instance that was previously allocated or deallocated or something. It would just load up an integer. It won't be 0 here, so that extra check to make sure it's not a hero and not a structure was needed. But here I'm actually removing the integer, so that's never ever going to happen. This is always going to be 0 unless it's a valid unit. So here I remove the instance from the unit, and then I start the timer and I delay it for 5 seconds. That means the unit won't respawn for 5 seconds. And if we go up now to on respawn, so this is run on the timer, it retrieves the instance using the timer, so it's another hash table lookup. Then it creates a unit using the owner right there, unit type ID, respawn loc, and respawn facing. And that sets its widget life to 5. And this is just so that it can continue to respawn over and over and die over and over again really, really fast, just for the demonstration. But normally you would not have this set widget life to 5 here. It would just be a create unit at loc. Now the instance is removed from the integer, or timer. Then the handles are cleaned up. So respawn loc is cleaned, timer is destroyed and cleaned, and then the instance is deallocated. So the unit respawns, and then it gets registered right here on enter, and instance allocated, stuff remade, and then it dies, destroys it, so it continues to create and destroy it. And that's why I said it could be made better. The create and destroy cycle right here isn't good, but it allows the code to be pretty simple like it is right now. And this is the hash table I'm using to store and read everything. So if we actually run this, it should now respawn the unit whenever it dies after 5 seconds. It's right here, wait, and now it's respawned, and then it dies, and that's respawned and dead again. And actually, multiple units could be placed. Neither of these were registered statically, they were both registered dynamically because of this onEnter trigger. So multiple units can be placed. So I can, for example, copy and surround this red footman. And now each of these will respawn at their specific locations every time. I could even run away and have them chase me, kill them, and they'll respawn right here, as you see. So a pretty good creep camp right there. And this is pretty much exactly the behavior you'd want for an ORPG. But again, the code backing it, because it's creating and destroying over and over again, it's not the best code. It could be a lot better. So triggers are pretty useful, I guess. They can run whatever code you want whenever an event happens, and you can put as much code onto a trigger as you want. Now let's check out the player enumeration. Of all the enumerations, the force player enum is probably the most interesting one. And the reason for this is because it has a filter on it that a Boolean expression can be passed into. There's also a counted force enum native. So right here, force enum players counted. So force, which force, Boolean expression filter, and then the count limit. So this is extremely useful if you want to evaluate a Boolean expression without adding it to a trigger, then evaluating the trigger, then cleaning the trigger up and removing it from the trigger, or whatever. Now keep in mind that a player is not added to the force unless the Boolean expression returns true. And this count limit refers to how many players are going to be added to the force. So in this case, the Boolean expressions need to return true in order to run this correctly. If they return false, they are going to run for every single player in the map. So let's go ahead and create a little force here. And that's going to force enum players counted, condition function this type dot test. I haven't made this yet, but I'm going to, and 1. Also, conditions don't actually have to return anything. And we are going to see what a condition returns if it doesn't return anything. So will this run one time or many times? Call print. Oh. Ah. But I have to do, where's F code C? Has to be done inside of this. Condition C, and then I can do call run F function this type dot test 1. Don't need that one at the end there. And now it works. So the trick to actually using this to make it so that a method does not have to return a Boolean when converting it to a condition is to pass it into a code variable here. Now let's see how many times this runs. And it ran one time. So what this means is that the method should be returning true, since it ran one time. And let's go ahead and do a trigger evaluation, trigger execute, just to see if it actually return true. So I'm going to do a call instead of this. Local trigger T, call trigger add condition T condition C, call trigger add action TC. If trigger evaluate T, then trigger execute T. And this is just going to see if the trigger evaluation returns true or false. And it only showed up one time, so it returned false. So it returns true here and false on the other one. We make it return false normally. Oh, that actually makes sense. It's only running one time for the force enum players counted because there's only one player in the map. So for a method, it always has to actually return the Boolean, and it needs to return true. You can't just have a method that returns no Boolean. Otherwise, this force enum counted will evaluate for every single player in the map, regardless of this count, because all the methods on it will return false, meaning no players will get added to the group. So just a little tidbit of information. And now if we go ahead and do uncomment this, it should show this message up here 2 times, since it now returns true. And there it is. So once again, a method that does not return anything returns false. A method that doesn't return anything cannot be used for forcing known players counted, because it will run for every player on the map. So just keep that in mind. And again, you need to know this trick here. Pass the function into another method or function as a code variable, and then wrap it in a condition if you want to make it return nothing. And this is useful for having dummy triggers like down here. You can put it inside of a trigger evaluation. It's not useful for trigger executions because the executions will never run, since this will end up returning false if it doesn't return anything. So it's just useful for trigger evaluations. And there are some libraries that do it this way. For example, Magtheridon 96's register player unit event library takes code variables and wraps them in conditions. That way you can pass in methods or functions that don't return anything. And let's go ahead and take a look at the respawn trigger one more time before we end this tutorial. So once again, whenever a unit enters the map, here's the setup. I'm going to create an instance for them and store it to their handle ID. So allocate an instance, store it to their handle ID, get their position, unit type ID, create a timer for them, that way I can delay the respawn and so on. And that unit has to be a regular unit, it can't be a hero or a structure. Here's the setup for it, for whenever a unit enters the world space. Here I'm catching all units that are already in the world space, I'm just moving them out and back in. And then here's the on death, and all that does is read the instance stored in the unit that I created down here. If there is no instance, return immediately. If there is, remove the instance. And this has to be done, otherwise there may be instances in other units that aren't valid, because the pointers for units are recycled in the handle table, and they're even recycled to other handle types. So over here I'm removing the instance, then starting the timer that will delay the respawn for 5 seconds. On respawn, I recreate the unit using all the fields I stored before. I'm removing the instance from the timer. This part also needs to be done because the handle IDs may change their types. It may become a unit the next time or whatever else, so it has to be done. It's also smart to remove integers because as the hash table fills up, it becomes slower and slower. Then I'm removing the location, so I'm cleaning up the leaks and destroying the timer and deallocating the instance. And once again, to see it work, I can run away from units and they will respawn at their original positions. So here I've run away, killing them all. Instead of respawning where they died, they are going to respawn at their original positions right here. And this type of setup is once again useful for placing creep camps directly on the map, just like this. So you could have a unit here, a unit there, a unit here, and a unit here. However, this is also a pretty simple system. Your creep camps, this position might have 5 different unit types, so you'd end up wanting to use a unit pool. Create unit pool, and what unit pools are sort of a randomized unit type. So you can add unit types to the pools with specific weights, and then you can get units from those pools. although I can't seem to find the native that actually creates a unit from the unit pool that's randomized. But using unit pools allows you to, for example, have a unit pool for a specific spawn position with 5 different unit types, and one might be exceedingly rare. And this type of idea is regularly used in RPGs. The units always spawn in the exact same positions, but different units may spawn at those positions. It may be a very rare unit. And then you may have to kill certain units in order to make this unit spawn, so it may have conditions to it as well as a unit pool. That concludes my tutorial.